Okay, so we're going to start out by talking about how to lay out your drawing views. And you notice it's really a matter of perspective because, for example, here we have this cylinder. And in one view, the cylinder is going to look like a rectangle, and in the other view, the cylinder looks like a circle. So how you lay out, yeah, that's pretty cool. Okay, so how you lay out your drawing really affects how somebody's going to interpret your drawing. Keep in mind that a lot of companies, they don't even use 2D drawings anymore. They just have you send them the SolidWorks model and they go from there. But a lot of companies still use 2D drawings. And the 2D drawings are used for two things. One, they're sent out to sheet metal houses or machine shops so that they can fabricate the parts. And the second thing they're used for is for inspection purposes. When the parts come back from the machine shop or the sheet metal part, the sheet metal house, somebody in the warehouse is going to check the parts against the drawings to make sure that the parts were made correctly and then accept receipt of those parts. So you're communicating with the drawing for two different reasons. One is going to be for the guy who's making the part, and one for the guy who's checking it for quality control to make sure it's made correctly. And they're really two different kind of purposes, and your drawing has to fill both of those purposes. They're talking about how you should lay out your drawing views in SolidWorks. Okay, so first thing is, we've talked about this on Tuesday, that the US and Canada uses third angle projection. The rest of the world uses first angle projection. Okay, and this is what first angle projection looks like. You have the front view, the top view, and the left side view, and that's not what we do here in this country. However, if you look at some of the drawings in the book, some of her drawings use first angle projection. So if you copy her drawing, you're going to be wrong simply by virtue of the fact that you're using the wrong projection, the wrong angle projection. So this is the layout used in the United States and Canada. We have the front, the top, and the side view, and because SolidWorks is so cool, we can put an isometric view or 3D view right here. Okay, and that's totally okay. So you can put a 3D view right in front, right on top of the side view next to the top view. And I'm going to be showing you how to create that layout in SolidWorks. But here's the problem in SolidWorks, and some of you are already seeing it because you're following the book and you see how she places her origin and how she orients the part. If you don't orient the part correctly in the first place, your views aren't going to be correct. So the first thing you should be thinking about when you're planning your parts is what's going to be your front view, because your top view and your right side view basically are projected off of that front view. So how you orient your part becomes very critical in how your drawing is going to look. So ANSI standards says minimal hidden lines, the heaviest part is on the bottom, use the most basic profile. That's how you select your front view. And I'm going to show you like what not to do, what to do. Yes?
Is the reason why they want the heaviest part on the bottom for the actual manufacturing purposes, or is that just...
No, it has to do with just what 8 mechanical engineers in a room decided. Okay? And these are the most boring guys on the planet, I got to tell you. All right? So notice here you're showing you see the part on the left side, and then this is an example of a poor layout. And the reason why it's a poor layout is if you look at, it's got a stable position, but on the right side view it's got too many hidden lines, which makes it difficult for the person reading the drawing to see where the edges are going to be. Okay, this has an unstable position and too many hidden lines. So I'm showing you all the bad ways to do it, how not to do it, so you can see why it would look wrong. And after a while, you'll just kind of get a sense of what looks right. So here you've got the same part, and it's like your part's got 6 sides, so the odds are against you. You know, you got 5 wrong ways and 1 right way. All right, so again, you've got the poor choice here for the front view and the poor choice for the right side view because it's not showing you the most basic profile. Okay, here you've got an unstable position, but you got rid of the hidden lines. Okay, and this is kind of how I feel grading your papers a lot of the times. Okay, now this is your good choice for a front view. It's the most stable and it's going to eliminate most of your hidden lines. So here's an example. Here's a good layout. You've got the isometric view, and then I'm showing you the front view, the top view, and the side view, and you can see the right side view has hidden lines, but it's the most stable, and we've eliminated most of the hidden lines. So here are the basic rules. We're going to use third angle projection. Your front view, when you pick it, should have the most basic profile, the fewest hidden lines, most stable position. Any questions? Yes?
What is meant by the most stable position?
Meaning that you've got the heaviest part, that if you were looking at it, it's not going to tip over.
Like the actual part?
Right, if it was an actual part. Okay, so that's that one.
Fixing with assembly?
Correct. Okay, so now we're going to talk about dimensioning. Okay, and this is another part. So here are the 2 downfalls: picking the wrong drawing layout, wrong way the views are set up, and the other problems are going to be dimensioning. Okay, first is you want to center the text, and I showed you how if you set up your template to have the center of the text enabled, that eliminates that problem. Now, if you don't set up your template correctly, you know, all bets are off. Okay. Second thing is you always want to start out the drawing showing your overall parts. You want the overall height, length, and depth. All right. Place those dimensions first, and right away you're going to be in good shape. Why do you want your overall dimensions? You want your overall dimensions because that's how the fabricator can determine how much material he's going to need to fabricate your part for quoting purposes. If he has to do math to determine the overall dimensions, he's going to charge you for the amount of time he has to take to make those calculations. So this is about being nice to the guy at the machine shop. And you want the guy in the machine shop and the sheet metal shop to like you, because he's going to be you want him to be your good friend, because he's going to produce your parts and you want him to do a good job. The other thing that's really important is these dimensions should be between the views. Notice that the height is between the views and the length is between the views. So 2 of the dimensions should always be between the views. And the reason is that way you can see how the edges line up on the views. Okay, it's a nice, you know, it's kind of like a sanity check for them figuring out how the part's going to lay out. So if you always add those 3 dimensions first, you know, and you put them in the correct locations, you're always going to be good. All right. Second, you always want to place the shortest dimensions closest to the view. Okay, because it's easier to read. Look how nice and easy this is to read versus this. Okay? So again, it's talking about keeping things clean, easy to read. And you always want to keep your dimensions outside and away from the object. You do not put dimensions on top of the object in the model. Okay? Leaders should be 30 to 60 degrees. And so notice that I've got an angle here that's at 30 and an angle here that's at 60, and my leader is between those two angles. I don't have my leader like this, and I don't have my leader out like that. Just makes it nice, easy, clean. And again, those angles, that's ANSI standard. I did not make these rules. These rules were made by those 8 guys. Yes?
You don't want us to start a voltage machine,
You don't have to do overmention in this class. Some companies want you to do overmention. Some companies don't. So
we don't need to.
You don't need to do it in your drawings. Okay. Okay. When you're dimensioning a hole, you want your leader line to align up with that center of the circle. Notice how this is offset from the center? This is correct. All right, that's what you want to do. Okay. You notice how they've dimensioned the chamfer, how they're dimensioning the circle, how they're dimensioning the radius. Okay. Notice how the angle of all the leaders is between the 30 and the 60 degrees. Okay, so let's look at this part. There are 2 things that you're dimensioning when you place dimension. First is the size of the feature, and the second is the location of the feature. So if you're looking at this hole, for example, you're giving the size, and you're saying where it is in relationship to an edge or another feature. All right? So here we've got a little cutout, and you're given the size. So when I'm creating a drawing, I look at every single feature, and I check to see whether I provided the size and the location for that feature. If I haven't, what's going to happen is I'm going to get a phone call from the machine shop saying, I'm missing the dimension. What is it? Even if I've given them the model to go with the drawing, they're still going to call me up because they want me to be responsible for the size and the dimension. They don't want it to be on their head because they know that if the part isn't made correctly, I'm not going to pay for it. Right? So if they have to call me up and ask me that question, they bill me for that time. Okay? So my parts then become more expensive if I haven't made my drawings correctly. So if you're on the job and you haven't dimensioned your drawing correctly and your parts are more expensive than the parts of the guy sitting next to you, do you think your boss might ask you why? Okay, so you need to kind of be aware of where the money and expense goes. And if your parts are less expensive than the guy next to you, you become a more valuable employee. You're more likely to get a raise. So would you rather the money went into your pocket or the machine shop guy's pocket? You know, you want to think about that. Okay, so when you have a small radius, you're going to put the arrowhead on the outside. Now SolidWorks will actually manage this for you, so you don't really have to worry about it too much. Now you can manually fix how the arrowhead gets placed, and I'll show you how to do that. Okay, when you're defining a hole, you always dimension on the profile of the hole. I never want to see this. You never dimension to the center line of a hole like this. You always dimension here. Question? Oh, that's a section.
Yes.
Yeah, but it's still the center line.
Oh.
Okay? So I don't want to see like this. I want to see what's on the very top view. Okay? Okay, now let's talk about when you're dimensioning holes. Like for one of your homework assignments was that 9-hole bar, flat bar. How do you dimension 9 holes? All right, so you've got a bunch of choices here. All of these dimensioning methods are okay. Some of them are better than others. For example, I don't really like this because this takes up a whole page, right? It's considered correct, but I'm not necessarily happy with it. The other thing you should know is remember that this part has 2 purposes. One is how to fabricate and one is how to check. How it's going to tolerance is going to be based on how you dimension it. So all of these are being dimensioned from this edge. They're all being dimensioned individually. So each hole has to hold tolerance to this edge. Okay? Over there on the top one, you've got what's called stack up. Because if the first hole's off by 0.05 and then the second hole's off by 0.05 and the third hole's off by 0.05, what happens to that last 9th hole? It's way out in Pluto, right? In terms of lining it up with whatever it's supposed to line up to. So while A is correct, if you've got a stack-up issue with tolerancing, it could create issues. Now notice you have 6 spaces at, and then here it's saying, okay, from here to here the distance is this and this is the tolerance. And these all have to be so much distant, 0.25 or 0.5 apart. Now they've all got to stay within tolerance of each other. You're not going to have the same tolerance stack-up issue. So again, this goes to how much you want to control. Okay, so now let's talk about double dimensioning. This is something I see in your drawings all the time. If you double dimension, you have to think about the guy who's inspecting the part. When the guy's inspecting the part, what he has is he has the part in front of him and he has the drawing in front of him. And I've watched him doing this, so I know this. Is they usually have the drawing and they have a marker, a yellow highlighter or red or whatever. And as they check each dimension, they'll check it off or highlight it. So if they see 0.62, he'll measure that edge, 0.62, highlight, check. Then he sees 0.62 in that view, he'll check it, highlight, check it off. What did he just do? He just checked the same edge twice. So he's added time to his inspection process. If he has to do 10 parts out of the lot, that's a lot of time. It's not good. Okay? It's costing your company money. You don't want to do it. Okay. This is also a double dimension. Even though this dimension only appears once, why is it a double dimension? Right. Because if you do the math, you don't need this dimension, right? It would be overdefined as a sketch, right?
Unless they were different.
How would they be different?
So one was 0.30 and the other was
No, but if you have the overall dimension, you have 1.0 minus 0.25, 0.5 is still going to equal whatever this edge is, right?
Yeah.
Right? All you have to do is algebra. And I know y'all know algebra. Right? Yeah.
Is it okay to do that? Like make the 0.25 on the right as the right dimension for purpose of checking and
You can use, well, I'm going to show you how to create it as a reference dimension. Reference dimension. You can do it as a reference dimension.
That's okay.
And that's okay. But if you set it as a reference dimension, as he said, what that means is you don't have to inspect for it. Right? It's just there for reference, for checking purposes, but you're not having to actually do the math. Okay, so you can omit it or you can make it a reference dimension. To make it a reference dimension, you just add parentheses. Okay, and parentheses just automatically means this is a reference just for your informational purposes. Okay?
So when do we want to make it a reference?
Some people like to do it. I normally don't, simply because there are so many people out there that have problems reading drawings that I don't want to confuse them. Also, there's a notation for an inspection dimension. So if you want someone to absolutely check a dimension, you put it in a box. And a lot of people confuse the box with parentheses. And so now your parentheses has actually had the opposite effect of what you wanted. So I'm kind of very cautious about using reference dimensions. Okay, so here are some errors. Okay, we've got a dimension on top of the object and to the two center lines. That's bad. Don't do that. Also, notice that you've dimensioned the size of the holes on the top like that with liters. No. You always do it to a profile of a hole. So I never want to see a drawing like that. Okay, so here's your checklist for creating your drawing. First, you're going to create your 4 views: front, top, right, and ISO. Then you're going to place your overall dimensions first. 2 out of 3 of the overall dimensions should go between the views, right? The front, top, and right views should all show hidden lines, if there's any hidden lines. So they should be set to hidden line format. The ISO view should be shaded or hidden lines removed. This is ANSI standard. Holes should be dimensioned using the hole callout tool. The reason why is because that way you're always going to get the depth of the hole. All right? Dimension from holes should always be placed on the hole's profile view. I don't want to see dimensions to hidden lines or center lines. Do not dimension the center point or the origin of the part. In a lot of her drawings in the book, she's got dimensions going from the origin or the center of the part. The problem with that is if you're taking a caliper, you can't caliper to an origin or a center point of a part. That's a mythical creature like a unicorn. All right? Nobody can caliper to that. All right? And the purpose of the drawing is not only for fabrication but also for inspection purposes. Do not copy the drawings in the text. That's a huge rule. If you copy the drawing in the text, they are not then to ANSI standard. Okay? So if you give me a drawing that looks exactly like something in the text and I hand it back to you with a very low grade, do not look at me with a smiley, innocent face saying, but that's what it looks like in the book. Okay? I'm telling you right now, if you copy what's in the book, you're not going to get a good grade.
This is the previous slide.
Yeah, that's it.
Now, both of the PowerPoints that you see tonight, you can download those from Ngrave. You can also download them from my Laney faculty website. Okay, and this is going to be part of the video that I'm going to upload over the weekend. So you'll have that also as part of the video series. Okay, so you should have 2 drawing templates, one for inches and one for millimeters. That's what we did on Tuesday, right? So you're ready to go? Both templates should be set to ANSI standard, not to ISO. You're going to use Arial font, liters to bent. Go through all your dimension settings, double check them to make sure everything's good. Save your template in sheet mode, not sheet format mode. Because if you put it in sheet format mode, when you open it up, you're not going to see any of your views. All right? And make sure you save your templates in your templates folder. right? Because those are all things that are going to help you be successful. Okay, last slide. Check your drawing before you hand it in. If you can, get a partner in the class, you check his drawings, he checks your drawings before you hand them in to me. Saves us both a lot of grief and you a little bit of humiliation. Right? So if you can find a checker buddy, and I do this at work too. I have people at work where I give them my drawings to check and they give me their stuff to check before I give it to my manager. You know, and then if we find something major in the other person's work, they owe you lunch, which is even better. So, if you can find a checker buddy in class that's going to help you, you grade a lot. You'll learn a lot from each other. Any questions before we get to the drawing part? Okay. All right here.